So energy on this side would mean it's endothermic. It's taking in energy. If energy is being released on the product side, energy is exiting, releases energy would be exothermic. So if you're making energy, exothermic, it's exiting. If you need to add energy, on the left side, it'd be endothermic. Harpy, what's you thinking?
What does the plus mean?
The plus up here?
Yeah.
That just means these two things are reacting. Over here, this plus just means both of these things are being made. So it's like this reacts with this to make this and this. Synthesis. This is a little review from yesterday, but we'll kind of break it down a little bit more so it won't be as rushed. Be sure you're asking questions if I'm not making sense. But synthesis, another often word we use to describe this is combination reaction. So synthesis or combination are the same type of reaction. Two things combining to form one thing. So if these are two separate things, they combine to form one compound. Cat eats fish. These are two reactants making one fat cat or a catfish. Down here, you can see this pattern. AB making AB. Hydrogen is your A. Oxygen is your B. So A plus B makes one compound, AB. Or over here, sodium would be like your A. Chlorine would be like your B. And again, you have two things combining to form one thing. That's the pattern that's going to help you identify synthesis reactions. Two separate things combining to form one. Another way you can tell it's synthesis, Josh, is if you have one compound, one product. If you have one product over here, you know it has to be synthesis. So today, what you want to start practicing is being able to identify, hey, can you figure out what reaction this is using this pattern or what you know about it? Decomposition, exactly the opposite. We talked about that yesterday, how it's the opposite. Instead of two things becoming one, you start with one thing and it breaks down into many. Decomposition, I think some of you said like rotten apples. I said roadkill because every time you drive by it, it seems to break down even more and more. It's about the breaking down of one reactant into two or more products. One thing breaking down into many. One unhatched egg breaking down into eggshell and chick. So if you ever start with one compound, the only way to create something new is if you break it apart. So that's one clue that will always tell you. If you start with one reactant, it has to be decomposition, because the only way you're going to get something new is if you break it apart. So here, this would be like, again, hydrogen's like my A, oxygen's like my B. So we have one thing, one compound, breaking down into its different parts. And again, over here, same difference. Is calcium is my A, and sulfur is my B. It works out and follows that same pattern. You have one thing breaking down into multiple things. So that's decomposition. Synthesis, two things, one. Decomposition, one thing, break down into many. On test day, you'll want to look at this and be able to say, oh, that's decomposition. Starts with one thing, breaks down into many. Or AB, separating into A and B. Combustion. Notice how there's no A, B, C, D pattern for this. That's why I referred to it as Weird Uncle Fester yesterday, because it doesn't fit an A, B, C, D pattern.